In this third lesson for sequences and series, we are going to look at the proof of an arithmetic series. So the proof is something that you have to study, and you must know how we write down everything all the way to the end, right? So let me start it over here. We have the sigma notation, but this just means sum of, and we can have n equals to 1, and can have ltn is equals to sn. That's where we can start off our expression. But what we trying to say here is that let Sn represent the sum of all the terms that you would add in an arithmetic sequence, right? So you would add the first term and you would add the other term. So it's a plus d. This is the second term. You add the third term as well. Let's go a plus 2d. Remember, we can write these terms like that, right? Remember, I told you term 3 is equivalent to a plus 2d. We already learned that. Okay, so this is how it goes, and then we can keep on doing this all the way till we add the very last term, and the term just before that we can call it the last term minus the difference, right? The constant difference. And the term before that, we can actually call it the last term minus 2 times the constant difference. Because remember, that's how you'll be moving. So from the last term, let's say the last term is 10. How do I go back? I just subtract the constant difference and I get the next term, right? So since it's a series, we have the pluses here. So that's how we formulate that first equation over here. And we want to write down the second equation, whereby we start in the opposite direction. We start with the last term, and then we are going to have the last term minus the constant difference, the last term minus the constant difference, and then we say plus, we have the last term minus the 2 times the constant difference, say plus all the way till we have at the very end the first term, right? And then we're going to have the second term. Remember, the second term is a plus d. And we have the third term. And the third term will be a plus 2d. And that's what we have. Now we take these two equations. And we're going to subtract them. We want to add them from with each other. So I have Sn plus Sn, that gives us 2 Sn's. Now add these values like this, and you'll see something. You will see that this term and the last term will form a plus L plus a plus L again, while the d plus minus d are going to cancel out. Then here, the two d's are going to cancel out. So you're left with the a plus L again, plus all the way here, even you'll see that the d's will actually cancel each other out. Then you have an a plus L, and you have another a plus L, and then you have another a plus L at the very end. So it depends on how many terms you actually added that will determine how many a plus L you are adding. So because of that, we can say it's n times, depends on how many terms. So we don't know how many terms you'll be adding, so it's n times a plus L. Remember, the a is your first term, while L is your last term, as we have explained it over there. See? So this, when we take the 2 over to the other side, you're going to have n over 2 bracket a plus L. And this forms our very first formula that we use to work out the sum of an arithmetic series. Now we need to know this proof that I just given you here. And if I substitute L, remember we do know how to find L. We can use the formula Tn is equals to A bracket n minus 1 D, right? So this would be the L. So L is equals to A plus n minus 1 D. So we can substitute that in there. And when we do that, let's use blue. So when we do that, we're going to have n over 2. Then we have A plus A bracket n minus 1 D. And when you simplify this, it gives you another formula to work out the sum of if you do not have the last term. So if you do not have the last term, then this is the formula that you will use to work out the sum of an arithmetic series. So remember over here, sorry, I need to put a plus. So remember here you have an A, and an A gives you 2A, and then this term stays as it is. So these are the two formulae that we're going to use to work out the sum of an arithmetic sequence. So make sure you know how to do this proof on your own, because it is examinable.